guys, first of all, let me introduce myself and to say a few words. Who am I and why I'm here? My name is Tetiana Fydorenchyk, and I'm Vice President of Marketing in Jelastic company. And some of you might heard already that Jelastic has been acquired this week. We announced that has been acquired by Virtuosa team. And now we are a big family together. So I'm one step in leading product marketing in Virtuosa. So big changes ahead, and we are excited about this news and hope that this will bring good results. Soon you will see those results for sure as customers, as partners, and we can work on that all together. So in cloud hosting industry, I'm already working about 10 years. And involved in different projects, especially in Java projects as well. Something like Jakarta working group, I'm a marketing committee there, also microprofile working group member, trying to be in touch with user groups of developers, Java developers, and not only. And also, I'm working on different articles and technical articles and also business articles to produce some useful content for the community. And as well as speaking at the events as today. So today we are going to talk about Java inside containers, inside virtual machines, what are the differences, what can work more efficiently and why. How the scaling is going to work within virtual machines, within containers as well, and some interesting points about overcoming the waste inside Java. So let's get started with the virtualization, first of all, and we can say that today we can cover three directions, like application containers, system containers, and virtual machines. If we are talking about application containers, right now, everyone will remind in the head the name Docker, because like somewhere in 2015, Docker made some kind of boom in containerization. And one of the reasons is that they made containers more convenient and more efficient for developers. Previously, containers existed already, like for quite some time. So at the moment, for containers is like more than 20 years old, the usual ones. So, but at the early stage, containers were more targeted on system administrators, on admin guys, ops guys. Docker made this more convenient and more open for developers guys, for them to easily provision containers, for them to easily work with them, manage, scale, and so on and so forth. And but at the same time, application containers, they usually run inside virtual machines or inside system containers because they need more isolation, they need more protection. So if you are talking about system containers, we can highlight some Linux containers for sure, and also Virtuosa containers that are in the market for about 20 years. And this is a production-ready solution. We are using in Jelastic it already for 10 years as well. And the difference between system containers and virtual machines is rather small in terms of what you can run inside. Because system containers, they have also good isolation. They can run several services inside, but at the same time, they combine the features of application containers. They are scalable, they are fast to provision, and that's why this is a good combination of both application containers and virtual machines. And for sure, if we are talking about virtual machines, these are like Hyper-V, VMware, some KVM options popular among developers. And if we compare application containers to system containers, what is used for what, we can have like high-level comparison that application container presupposes that you run one single service inside. And in case of system container, you can run several of them. You can run one major system service and also some extra ones. So you can run your server and, for example, SSH daemon and some other services around it. So this is like the main idea between them. So how to use this infrastructure in effective way? What can be more effective? Let's see at this point taking Kubernetes hosting as an example, because right now many customers and many developers and companies, they're using Kubernetes in order to manage containers and to run them properly. And if we compare running Kubernetes on top of virtual machines and containers, we can see that with virtual machines, there is some kind of overhead because of the guest OS. And as a result, you need to pay more and you need to consume more resources. That in case with container-based hosting, you will not have this overhead because these resources can be consumed by the application itself, by the servers itself. So we saw this kind of difference and decided that this kind of nested architecture can be much more efficient for our customers if we run application containers inside system containers without using virtual machines, omitting this layer. You can see the difference if you take, for example, a full host. The difference is even more visible because you will have this overhead in each virtual machine that you're running within the host, and this overhead is much less if we are talking about container-based host. As a result, all these resources will be divided like for the overhead usage, also for the resources that are really in use. Within the virtual machine, you still have some extra resources just in case that are going to be reserved in case if the load goes up and you need to have some extra resources, but you're still going to pay for them, no matter whether they are used or not. In case with container-based host, all those resources that are not in use, they will be available for reusage by other applications, by your other services, by your other containers. And you're not going to pay for them in this case. Of course, most of the cloud vendors, they are running containers inside virtual machines. And in order to have some kind of interoperability cross-cloud one, you can run this kind of nested style architecture, and you can run containers inside virtual machines. In this way, this is also a possible way out if you need to have cross-cloud deployment, and you can run them on all those cloud vendors without the need to remake the project for every cloud separately, because virtual machines are going to be supported everywhere. And talking about this cross-cloud deployment, so we also practiced some way of live migration across the clouds. So in case with Jelastic, we tested this solution. So we took several different cloud vendors, something like Amazon Web Services, Azure, and we checked how that works. And this can work properly with the right configurations. You can migrate one application from one cloud to the other cloud without any downtime. So we made a test using Minecraft game. So one person was playing Minecraft, and that was hosted on Amazon Web Services with the help of Jelastic platform. And we migrated this on the fly without stopping. So the person was playing and we were making a video out of that. So to make sure that there are no interruptions for the end customers. for running their applications. So there were no glitch, no stopping of the game at all. That's pretty cool, and this makes it possible to get in future like all these cross-cloud deployments much easily, and also much simplified in management. If you are talking about scaling Java inside VMs and inside containers, we can compare that on the low level. So if you take virtual machine, as I was already mentioning, virtual machine, you buy the full one. And usually you buy bigger machine than you really need at the moment, because you understand that the project is going to grow. You will need some extra resources in case of load spike, or in case of any extra activities planned. So you buy the virtual machine, the full one, and you pay for all of it. And all the resources are reserved, and you are paying for them, but at the same time, part of them are wasted because they cannot be shared with other virtual machines. They are fully reserved. In case with container, you have some used resources, and the rest of the resources are going to be shared with other containers, and they will be available for reusage. Even if we are talking about then horizontal scaling, you will see this kind of inefficiency across virtual machines in every virtual machine that you have, because in every virtual machine you will have some kind of overhead on top. Talking about vertical scaling, when you decide that, okay, my virtual machine is too small for me already, and the project is growing really well, and we need to go for more resources, you will choose a bigger virtual machine, and you will need to migrate from smaller one to bigger one. And usually the scaling step is not that small. The scaling step is twice bigger. So if you started with 2 gigabytes, then you will move to 4 gigabytes, then to 8, and so on and so forth. And every time you need to grow vertically, more than you have inside the virtual machine, you will have extra work to do, and also you most likely will have a downtime during this migration. So that might be rather inefficient in this case. If you are talking about containers scaling vertically, the container itself is going to bring extra resources inside, and you will not need to migrate from one container to the bigger one. The container itself is going to grow bigger or shrink when you don't need those resources on the fly. So no need to move from smaller to bigger piece and doing extra job here, or losing extra customers because of the downtimes or some stuff like that. And if you are talking about Java in more details, like how Java is scaled and what should be considered inside Java, we can look at this like container with Java inside, with JVM inside, and you can see that inside the Java, you have inside the JVM, you have separate blocks, and each of these blocks has its own limits. So XMX is one of the main ones, because you run the main project there, you run your application there, like the main objects. For example, inside Elastic, we set up this XMX for 80% out of the whole size of the container. Also, there is matter space size parameter that is responsible for storing different system files, like system information about classes, about some internal objects, and some stuff like that. As well, there is direct memory piece that is responsible for storing some stuff outside of the XMX. outside of the main part in order to process it faster. Usually this is used for cache and cache servers and some database processes as well. And of course, every thread has some kind of consumption of RAM inside, and there is a part for that as well inside. So altogether, you need to take into account each side or each part of this while configuring your Java for vertical scaling, because it's important to figure out what kind of limits you're going to have for each side. For example, if you're talking about Jelastic, in our case, we set up these limits automatically for the customers. So, for example, if you change the number of resources available for the container, the system automatically will adjust the limits of every piece inside. And for example, right now, in order to adjust all this stuff, we need to restart the container. And this is a kind of drawback at the moment because still restarting can lead to some downtimes and some stuff like that. But at the same time, you cannot do that in any other way anywhere right now. This functionality is not yet ready. And we are working with OpenJDK community in order to figure out and to introduce the solution that will help to adjust these scaling limits without downtime, without restarting, and adjust like all limits inside the runtime for Java. And currently, like with all this scaling, like we adjust everything, so you won't need to do this manually. You won't need to go inside Java and make the adjustments by yourself. This will be done by the system. So this is already a good point because you won't waste time on that. And what are the cases, how this scaling can work in general? So the ideal case is when the XMX limits are rather close to the limits of the container itself, and then you will have some kind of used resources and also some available resources for the future growth. And but there are also other cases how that can work. For example, sometimes you can set up XMX too low, so you will have some kind of over allocation because some resources that will be outside of these XMX limits, they will be still reserved, especially if you're talking about virtual machine inside. So they will be still reserved inside virtual machine, but they are not going to be used because the XMX limit is too low. The same issue can be with under allocation. When you set up XMX very high, this can lead at some point when the usage of the resources grow. This can lead to out of memory exception or even out of memory kills. And as a result, your JVM will be killed and by the operating system. So this is also a bad case. That's why it's important to be very precise with choosing the right limits and very precise with specific parameters. And here are some parameters that are important to take into account while running JVM inside containers. So in order to set up the limits, first of all, one of them is use container support. And this parameter forces JVM to use container limit instead of the host limits. This kind of parameter is used for application containers mostly, not that necessary for system containers at the moment. If you're talking about parameter initial RAM percentage, you can set up initial heap size as a percentage. out of the total memory that you have. And as well, there is a parameter max RAM percentage that set up maximum heap size as well, like in comparison to the total memory that is available inside. Java in generally considered rather greedy for the resources, and rather often people are talking like, yeah, Java is cool technology, but it consumes a lot of resources. And even some time ago, there were some developer survey, and one of the reasons why they're not using Java, or what kind of issues they have with Java, there was mentioned that this memory requirement is too large, and the consumption of memory is too big. Currently, this problem is solved partially, and some extra options are also considered right now to solve this issue. So step by step, Java becoming more efficient and more scalable in terms of resource consumption and allocation. And let's see what kind of issue we had before. For example, one of the problems we had that was unreleased heap memory. If you see this graphic, the blue part is the really used real consumption by objects. So this is the real consumption. If you say about orange part, this is the reserved resources by JVM from operating system. And basically the problem was that JVM, if it had the limits, it didn't release those reserved resources. Even if it didn't use it, it still keeps it inside, and operating system cannot reuse it for other purposes. And there were made one improvement here. So this improvement is available starting from Java 12. And the idea is that JVM brings back unused memory to operating system. So garbage collector automatically works out and gives the possibility for JVM to bring back those unused resources, and operating system as a result can reuse these resources for other services. So let's see how that works right now with these improvements. So as you see, used heap is at the same level as the reserved heap here. And only after dropping, there is some extra usage, but this is not that big. This is just in case this used heap is going to grow again. And you see that there is also the limit, max heap, but within this limit and used heap, these resources are not reserved anymore. They are not kept anymore. They are released for the operating system. We were, Jelastic were involved in these improvements. So we were one of those who offered to make this improvement, and also found people who can implement it and test it, how that worked. And Java community saw this work, and in 2018 we got Java Jokes Choice Award. So this is like a Java Oscar, I would say. And that was really pleasant that our work didn't go away without notice. And at the same time, we made this not only for Jelastic customers, but for the whole Java community. We wanted to improve this inside Java, not only our platform. Because within our platform, even before this improvement, we had a special Java agent that we used for the same purpose in order to release those unused resources. And right now, this Java agent, it can be also used. It's useful for those who are running Java less than 12, because as I mentioned, this improvement available starting from Java 12. So right now, if you're using Java 11 or less, you can try to use this Java agent. And as a result, you will have the result something like that with full BC garbage collection. And here you will see that the result for sure not the best as it is with the improvements itself, but at least it also releases lots of resources when they are not used. And this is not the end of the improvements that Java is working on. So one of the improvements was implemented starting from Java 16. And this improvement connected with returning unused hotspot class metadata memory for the operating system. Also, there was reduced meta space footprint and simplified the meta space code in general. So as a result, these reduced maintenance costs. So this also makes Java more efficient, and this is again not the end of that. Right now, Java platform provider, they are working on the coordinated restore and checkpoint project. And this project aims to adjust Java API in order to coordinate between application and runtime in order to save and restore the state properly. And in this way, there can be saved also extra resources. Right now, this project is ongoing in process. So soon, I hope we will see really good results out of that. And of course, when we are talking about efficiency, it is important not only how resources are consumed and allocated, but also important how they are charged. Because even if you're going to set up everything properly for the consumption, and you will not be consuming more than you really need, in most cases, you still can pay more because the charging model or the billing model can differ from what you expect. So I would like to highlight the difference between the pay-per-use and pay-as-you-go system, because pay-as-you-go system right now is rather popular among cloud vendors, but you need to realize the difference, and you need to realize that pay-as-you-go is not really pay for what you actually use. So if you take if you take cloud vendors with pay-as-you-go system, most of them, and I would say like all of them, are using VM-based hosting. So in this case, you still buy the whole virtual machine and you still pay for the whole virtual machine, no matter how much resources inside you're using. So this is like back to the topic that we were discussing. So this vertical scaling. So you buy a bigger machine, so you go, so pay as you go. So you start with smaller one, you go to the bigger one, you pay for the bigger one, then you go to much bigger, then you pay for this one. So this is like pay as you go. Yes, but at the same time, the real consumption is still not the same as the whole virtual machine. So in this case, container helps to make the pricing more scalable. And for example, in Jelastic, we introduced pay-as-you-use pricing model. In this case, customers doesn't need to reserve resources. They can set up maximum scaling limit that they think that their application can grow up to. But at the same time, they're not going to pay for this maximum limit. They're going to pay only for those resources that they are really consuming. So I would go to the dashboard. So this is the dashboard of Jelastic. I will show how we do that inside. For example, while creating the environment, the client can choose like what language they prefer, what application server or database they want to go with. And here they can set up maximum scaling limit for the resources. So for example, I can set up like 10 gigabytes RAM, and the minimum I can set up as small as 128 megabyte, or like I can start with 1 gigabyte if I know that my application for sure will consume this 1 gigabyte. It's useful to set up these reserved resources because they are cheaper usually when the dynamic ones, but at the same time, you are not going to pay for all these 10 gigabytes for the whole scaling limit. You are going to pay for the specific amount that you're going to use. For example, if you use 4 gigabytes, you will pay for 4 gigabytes. If you use like 9 gigabytes, you're going to pay for them. But this will be dynamically tuned by the system. The system checks how much resources you need at the moment, provides those resources or takes them back out of your application if they're not needed, and you're paying like for every piece of these resources within these limits. The system will not go out of the limits here. So, this is rather normal practice, I would say, because if you go inside like Linux or Windows or macOS, you will see that they also have like total memory, and also they have some used memory inside. So these are two different options. Same for cloud resources. There should be some kind of physical memory that is available inside, and also used memory that customers are using inside. So the same for the Windows, you can see as well, like total and used resources. That is why on the market right now, on the cloud market, there is a kind of speculation with this term pay per use, because everyone is telling that you're paying for what you're using, but do they really mean that? So there are different options, and most likely on cloud vendors, you will see pay as you go, or pay as you allocate, or pay as you reserve. So basically, you're going to pay for the limits of the virtual machine that you're buying, and not for the resources that you are really consuming. So for example, if you are taking Amazon, you can see that they are saying you only pay for what you use as you use it. But then when you're buying the resources, you are warned that you build for the task memory and task CPU allocated. So this is not used, but allocated. So if you are buying like 4 CPUs, then you're paying for them. If you're buying 16 gigabytes, you're paying for 16 gigabytes. Same for the Google pay per use. In their case, this is more like pay per allocated limits. And why it's important, we gathered some statistics. We really hope that other cloud vendors will move to this direction as well. So we gathered statistics on all our data centers, like service providers with whom we are working, and we saw the difference. So if you see like these used resources, these are really consumed resources by the customers, real resources that are needed by the applications. And this red line, these are vertical scaling limit that our customers were setting up just in case of some growth. So they were setting up, okay, if there will be some growth, I need to have like these 10 gigabytes just in case. But the real usage was like much lower. And in case with other cloud vendors, they're going to pay for this red line, because they're going to buy the full virtual machine with the capacity like here. And in case with Elastic, they are paying only for the green part, because we have a real pay per actual consumption pricing model. This is like in short about the elasticity, and talking about running Java inside containers. And with containers, of course, we need to highlight some stuff about Kubernetes hosting, because right now Kubernetes is like having a big hype, and many clients, many customers, they go into Kubernetes, and they are preferring this way of their containers management. Kubernetes hosting is, and for Java as well, it's not that easy a thing that can be considered. So first of all, Kubernetes has like lots of different components to manage and to think about when you are running it. And also, this becomes like very high entry barrier for beginners. So not every developer and not even every system admin can work with Kubernetes and manage Kubernetes. So rather often they are afraid to step inside because they don't know what to expect there. So that was also like one stopper for the Kubernetes Java inside Kubernetes. And also Java projects, rather often these are big projects, they're running for years already on some specific traditional hosting and some stuff like that. So this is a big step to migrate them. So this is a big step to migrate from traditional VPS or for some virtual machines inside Kubernetes. So this is a huge sometimes, especially with some complex applications. Kubernetes was designed also for large-scale cloud-native applications and some microservices, and sometimes for some traditional applications, it's not really the best choice that can work. As well as further management, this can be a big pain for clients, like updating the versions, managing all the stuff like scaling and so on and so forth. So that's why we started to work on this Kubernetes direction as well, to see how we can help here. So first of all, we wanted to make Kubernetes more open for those who doesn't have enough experience. So for them to get started easily, we offered automated installation of Kubernetes. And you can see that this automated installation is available within the marketplace that we have. So we have clustered options. Here you can find different clustered options, and one of them is Kubernetes cluster. So within this Kubernetes cluster, customers can choose different versions. They can go on with the preferred Kubernetes version. Also, they can decide what kind of dashboard they want to use for the Kubernetes management. And they can get started with some specific topology. This can be development topology, or this can be production topology. The difference between them is in the number of nodes, in the number of workers inside, and also in the number of nodes in general, so for management as well. So they can go with production, for example, and as well choose ingress controllers, so for balancing like HA proxy or nginx or traffic. Again, you can go on with clean cluster without anything inside, like, and then you can deploy whatever you need. Or you can go with custom option, and here by default we are offering Open Liberty project inside. So if you choose this custom one, you can either paste here already your project that you want to deploy at once, or you can use our project, and as a result you will get Kubernetes with Open Liberty inside out of the box. Again, you can attach NFS storage if it's required, or disable it. And you can also enable some modules out of box, so something like Prometheus, Grafana, Jagger, also remote API access. So all this stuff will be available just when you click on these. Just tick the buttons and you will get all this functionality inside. You just paste the name of this environment, also with some of the data centers and service providers we are working with. They offer multi-region deployment, so they have different regions, so you can choose the region where you want to install these Kubernetes. And Kubernetes. So yeah, let's have like this. So you can install this Kubernetes and just click install. And all the process is going to be done automatically here. You can just click on the button, so it will go down here. The process will be going, and you can keep working here. So before this call, I already created some Kubernetes cluster with cargo tracker and deployed cargo tracker inside. So basically, you just click open in browser, and you will have Jakarta project deployed and work with these. So you will have the workers, and you can manage them. Also, there will be some add-ons and configuration files, statistics. You can work with the statistics here. For example, you can see how much resources are used. Here you will see that 4 GB is set up as RAM limit. So this is this maximum limit that we set up. And 2 GB is the real consumption, like, or even less than 2 GB sometimes, 1.7 GB. Me as a client, as a customer, I'm going to pay only for this 1.7 GB, not for the 4 that I set up as a scaling limit. So here you can choose different options what to check, like within these statistics. Again, with the add-ons, there are options to have several add-ons, like, for example, environment start scheduler that can be helpful to cut the costs again. If you don't want to overpay for some stage or testing environments or development environments, you can install this add-on and enable the timing when this environment should be started and when it should be stopped, and choose the time zone and so on and so forth. And again, you don't need even to have big skills, technical skills to go inside to know where exactly you need to configure that. This is a kind of clicking the buttons at dawn, and you will have your environment starting and stopping in the right time when you really need this. So control panel, again, there are some add-ons, like more add-ons for these options. For example, one of the important add-ons that our customers really like, this is cluster upgrade. Again, this add-on helps to upgrade the Kubernetes cluster to the next version automatically. So basically, you click yes, and the process will start, and the application will be installed just in moments. So these are like some of the options that are available. Again, you need to understand that the cluster itself we built with the help of our partners and with the help of our customers, using their feedback based on what we are running inside. We compiled this package, made it possible to be installed automatically. And as a result, you can get all these vertical scaling, all these changing load resources on the fly. Also, you can get inside these workers and master nodes, their SSH inside the dashboard, and all these add-ons that I was mentioning. Because, for example, if you are talking about upgrade procedure, this is not that easy to move on if you do this manually. So the procedure is really time-consuming, and you need to know how to tune it, how to go from all these stages. So we automated this process for you not to worry about. So in addition to that, except solving all those challenges that I was mentioning higher, we also offer multi-region and multi-cloud Kubernetes hosting. So you can have Kubernetes federation inside, and this also can be configured easily for your applications. And you can also run it across different clouds or across different service providers who are using and offering Jelastic locally. So this is the case with Jelastic in general. And talking about Java, I can say that Java right now is already not greedy at all. So because you have the tools, you have the right tools how to make it scalable and efficient. And right now, this is like a matter of learning, a matter of trying. And if for sure, if you need some assistance with that, our platform, Jelastic platform, this is like acronym Java Elastic. We started as a Java platform initially, then only added other languages. So we have a good experience in Java, and our experts can help you with that. So in case you need to tune your Java project in order to make it efficient, to make it cost efficient and scalable, and then you can just drop us a message, get in touch with us, and we will help you to do that. So thank you for listening. I think that I'm already a bit out of time. So in case you have some questions, you can ask me in the chat. Any questions? And it seems to me everything was clear. I hope so. So in future, you can get in touch with me or with our team in general, and we will help you to make Java elastic and scalable. Have a wonderful continuation of the conference and hope to get in touch soon.